Good morning, sir.
Good morning, Gita. Good morning, everybody.
Sir, shall we start, sir?
Yeah, please.
Okay, sir.
So,
Very good morning to all participants. First of all, I would like to introduce our today's resource person, Madhusudanan, sir. He have completed his UG, PG degree and Doctor of Philosophy in Anna University, and he have over 20 research publications in SCI journals in the area of artificial intelligence and machine learning, data science, image processing, signal processing, wireless sensor network, and IoT. And he's a professional with 20 plus years of experience in business and technical aspects of product development from the discover and innovation stage to product launch. And he's also have 8 years of experience as adjunct professor at Anna University affiliated colleges. Now currently he is the faculty of BITS Pilani, and he rolled out artificial intelligence and machine learning solutions for EdTech, Agri-Tech, and greenhouse domain using wireless sensor network, image processing, and customized neural networks. He have developed and deployed embedded system-based solutions in medical and precision agricultural domain. He also have a strong functional knowledge in writing business proposals and developing proof of concept, and lead the product team from incubation and deployed biometric solutions for clients, including Precision Informatic and Bharat Electronic Limited. And he have built the edX services company, germinating an idea based on proven research techniques to a business model using artificial intelligence and machine learning with a small team of 18 people, and also involved in the market research for the business opportunity, planning, requirement, design and prototyping and testing stages, and also author the personality career mapping based on extensive research and localization using Riasec and other tools. He also designed the interview template generation tool independently using artificial intelligence machine learning with a high degree of supervised learning and design in patent research pending stage. He also leading the Department of AICT NAC compliance and engaged students' time to lifelong learning through hands-on training. Also lead the department research and development and enable funding through different agencies including AICT and DSP, and also provide academic solutions to engineering colleges and support in research proposals, handling conferences and train the trainers. Handled multiple workshops and research methodology, also prepare academics and students for research proposal presentation. And also he have handled over 100 hands-on training sessions in the area of artificial intelligence and machine learning using Vega and MATLAB. So on behalf of Department of Computer Science and Engineering, Excel Engineering College, I would like to welcome our today's resource person, Madhusudanan sir. Welcome you, sir.
thank you, Gita. Okay.
Now the session is handed to our resource person. Please, sir.
Yeah, thank you, Gita. Good morning, all. No, I'd see how many people are there here. So I see about 18 people. Okay, 18, maybe logistics. We have about 15, 16 participants. Okay. I would like to understand what is the outcome of your learning. That is what is very important. When you are attending an FDP, maybe you have multiple multiple reasons for doing this FDP. It could be with respect to your college requirements. It can be with respect to building your own knowledge. It could be with respect to changing your domain. Maybe you might have people who want to quit the teaching industry and go back to the a technology industry. It could be any one of these reasons. So now I am assuming what I try to do today is maybe before getting into algorithm engineering, which is my specialization, I would like to focus on your career path also. Reason why I am trying to highlight this is a couple of things. If you want to be in the education field, you all know that national education policy is going to come into force. Again, where the emphasis on practical knowledge. Secondly, alternatively, if you are planning to go to the industry, I think AI is one area which is extremely hot. I see a lot of people transitioning from a professor to industries, because I do a lot of mentorship for industries under various programs. I handle a lot of data science solutions for the industry, and I also see that there is a lot of requirement, and they want people. No, it is something. No, the field by itself is new, so people who are already there in the industry are slightly lost when it comes to the theoretical concept. But as you all being from computer science, IT departments, I'm fairly sure that you'd have handled machine learning as one of your subjects. So that is giving you some sort of theoretical background, and if you are able to understand data, taking it forward to the industry is absolutely not a problem. In fact, no, couple of I was pretty proud to see a couple of Anna University professors, affiliate college professors who are also in the industry. During my various interactions in the industry, I came across these people. Okay, so I would like the session to be interactive. You have any doubts, you can ask doubts, and then if I ask any questions, please feel free to answer. Make mistakes, you learn only by making mistakes. Okay. Now, before getting into big data, okay, big data is nothing but application of your basic machine learning algorithms on huge volume of data, which might have velocity. That means the data might be coming in continuously. Analyze it real time could be one scenario, or analyzing it offline could be another scenario. Classic case studies where big data analysis is happening is in the area of opinion mining and sentiment analysis. Okay. Now, when we look at, when we go back 15 years back, 15 or even 20 years back, I completed my graduation 25 years back. So now I'll say, if we go back 20 years back, the mantra was information technology. Even today you talk about it, anything, I am in the IT field, right? This scenario is changing. This scenario is totally changing. We are not talking of IT now. IT has become part of the system. We are moving from information technology to recommendation technologies. We are moving from information technology to recommendation technology. That means I am trying, we have reached the pinnacle of information technology, but we are evolving into recommendation. What is recommendation? Right? Think about it. 10 years back, when internet was not so popular, or 15 years back when we were all youngsters, if you want to buy something, about 15 years back, 15 is fair enough, 20 would be ideal, but I'll still stick on to 15 years back. If you want to buy something, what do? You ask your friends, you ask your relatives, right? They recommend. Now, everything is governed by your friend or relative, and the choices were also limited, and within that limited choices, you again made a sublimited choice. If you are from a small village background, if you are trying to buy something, you try to buy which everybody has. So that was then informal recommendation system. Now, for the last 7 years or 8 years, if you see what is happening, Flipkart came into existence, Amazon came into existence. Okay, they were there maybe slightly a longer period, but about 7-8 years back, the transition from offline to online has increased. The transition from offline to online has increased. Initially, there was a lot of apprehensions because you love to touch and feel it. But again, a lot of technology companies came in, like Myntra, Jabong. Okay, so if you talk about Myntra, what do they sell? They sell clothing and clothing accessories, or fashion and fashion accessories. So it can be a shirt, it can be a trouser, it can be a kurta, kurti, whatever it is. And maybe accessories to it. It can be clips, it can be powder, whatever accessories required for fashion. Now imagine their challenges. I can give you a real-time problem. Imagine their challenges. Now, have anybody, no, have you all purchased or no, have done purchase in Mintra? Forget Amazon. I think most of you must have done purchase in Amazon. Have you done in Mintra? Nobody. You can either no use your chat window or you can tell yes, no. Nobody has used Mintra. Come on, say yes or no. I'm not going forward until you tell me yes or no. I wanted you all guys to be interactive. No, no. Karpaga Priya says no. So nobody has experience in purchasing in Mintra. Okay, what about Amazon? Have you done a purchase in Amazon? You all would have done purchase in Amazon, right? You'd have bought some any item. It could be an electronic item. It can be a it can be yeah. I see a lot of yes, at least for Amazon. So no, we are still not mentally prepared for Mintra, where you want to buy material, buy dress material from Mintra. But things are changing, things are moving, people are moving from the online offline mode to the online mode. But Amazon, I see a lot of people raising their hands. So if you're looking at Amazon, if you look at Amazon, you do a purchase, now if you do not like a purchase, you have something called as a returns policy. Okay, so Amazon also sells dresses. Now let us say I am a very intelligent person, cunning person, cheap person, whatever definition you take it. I buy, I have a wedding day after tomorrow. I need to attend my friend's wedding day after tomorrow. So I go to Amazon. I'll buy a costly coat, a costly blazer, a costly shirt. Then I use it for the function. Next day is a function. I use it for the function. Then, after using it, I come back. I send a returns recommendation. I send a returns this thing. I say I don't want the dress. I have not liked it. Simple, right? The same can be applied for many of the items that are available in Amazon. It can be an expensive camera. I can buy the camera, take about 400, 500 photos of it. Take the backup in my laptop, then I'll say I don't want it. Maybe I'm going on a trip. So normally a return policy is for a couple of days, 3 days, 4 days, 5 days, whatever it is. Okay, now if Amazon says I do not have a return policy, you are not going to buy it. If Amazon says I have a return policy and you misuse it, you have a challenge. And this is where big data comes into picture. You look at the volumes, you look at the velocity. Typically, the volume is about 1 lakh transactions and odd per minute in India. Globally, it is much higher. If you look into the Amazon statistics, you will be able to see the type of volumes and the velocity at which data comes in is extremely high. Okay, the servers has to handle it. Today we have reached the IT pinnacle of IT system where you will be able to handle those data. But today the idea is, using this data, can I have a recommender system? Period. Okay, so that is where it is extremely important for all of you to understand that if you are looking at data science or big data, whatever name you call it, I use one single word. It is called as artificial intelligence. Within artificial intelligence, you have machine learning. If you have a data analyst who does only analysis of data, then you have data science. Data science is where you club machine learning with statistics. Okay, but all come under one hood called as artificial intelligence. And the entire goal of artificial intelligence is recommendation. When we talk about recommendation, I'm talking of the people sitting on the fence. If let us say I want to buy a car, I have decided on a Honda Amaze. Okay, the moment I have decided on Honda Amaze, nothing will make me change. That could be a good percentage of people. So there are 100 people who want to buy cars. 30 people will be very sure that I do not want to buy a Honda Amaze. That means I have 70 people. In this 70 people, you will have 20 people who are sitting on the fence. That means they are not decided whether to buy or not to buy. 50 will buy. I don't have a problem with them. I give them that additional 5,000 rupee discount, 2,000 rupees discount. The mind makes us buy. I'll tell you, I'll give you 2,000 rupees discount. But actually 2,000, when you look at 12 lakhs or 10 lakhs investment, 2,000 is very small, but the human mind makes you to buy that. But there are 20% of the people. 50 will buy, 30 will not buy, 20 will be sitting in the fence. That means somebody can drag them to buy another car. Hyundai can give them a marketing gimmick and then ask them to buy the car. Okay, with a population of 100 crores plus, how will you identify this person who is sitting in the fence? Right? I am not bothered about out of the 100 people, 50 people buying the Amaze car. I am not bothered at all, because they are definitely going to buy. I need to do marketing in a different way, offer them some discounts, give some insurance discount, talk more about the product, because mentally they are prepared. 30 is not going to buy. No point in beating a dead snake. The third scenario is the 20 people who are sitting in the middle. Okay, 20 people sitting in the middle comprises almost a huge number of people who want to, or who can be made to change their mind, either to buy the product or not buy the product. Okay, identifying this is part of your recommendation system or your recommender systems, and that is where the world is moving towards. From IT technology, it is going to recommender technologies, and that is where big data plays a critical role. I gave you two examples. One is the people sitting in the fence, which can generate billions and billions of dollars of business. The second group of people is the people, people in the Amazon scenario who try to beat the system. Okay, now if Amazon says I do not have a return policy, I'll not have people buying, the sales will come down, because you will have the genuine people who return genuinely may not be able to return the product, and becomes a loss to them. And of course you have the small amount of cheaters who try to find the loophole in the system and use it. Identifying this is another case study where data science can be applied, big data can be applied, and your system has to be very accurate, because it should dynamically point out the right person. So when we talk about all this, the thing that comes into the mind is whether it is data science, we are talking of data. Big data, we are talking of big data. Nothing, no, it's just a fancy name. Large amount of data, big data. It is about data. Now, when you're talking about data, you should be able to understand data before getting into algorithm engineering. So in the morning session, I'll focus on data, and in the afternoon session, I'll focus on algorithm engineering. Okay, to understand big data, first thing that you need to understand is you need to understand your basic you need to understand the basic data structures part of it, where you look at the time complexity. Time complexity becomes extremely important. What I'll do is I'll share my screen and my video. So you're able to see my screen?
No,
Somebody,
sir.
you're not able to see the screen? Okay. Are you able to see it now?
Yes, sir.
Okay, thank you. So here I use the word data for big data. First thing that you need to understand when you are handling big data is about the time complexity. Give you a very simple example. Let us say you want to buy a car. Okay, so you have decided on the model, you have decided, no, or no, if you look at, you want to pick a car randomly. No, you are very rich. There are about 300 models of car. No, you want to pick a car randomly. Let us look at the complexity for solving it. Or it can be anything else. It can be, buying a mobile phone. So there are hundreds of mobile phone designs in the market. So let us say you narrow down on, say, about 10 mobile phones. You narrow down on 10 mobile phones. In that, let us say you want to buy mobile phone for your entire family. So you want to buy 3 mobile phones. Now you pick up these 3 mobile phones, and if you try to understand, you have 3 mobile phones, and if you want to find out all the combinations that can be had for this 10 mobile phones, it is nothing but an NCR problem, right? It is NCR 10C3. So NCR states very clearly n factorial divided by n minus r factorial, n minus r factorial into r factorial, right? That is your NCR formula. So here you have n equals 10 and r equals 3. That means given 10 mobile phones, you want to identify, or no, you have selected 3 mobile phones, and these 3 mobile phones, all the combinations can be easily obtained using the combination problem, which is NCR. So 10C3 is nothing but 120. There are 120 combinations. So you have an Apple phone, you have various Samsung phones, you have various Apple phones. You have selected 10, and in that 10 randomly you pick 3 phones. What is the combination of getting the 3 phones is about 120. That means once you select it, if I write a small program for all these 10 phones, A1 to A10, and I select 3 randomly, A1, A5, A7, A1, A2, A3, A1, A8, A9. I select randomly. You have about 120 combinations. Now, what is the relationship between this and big data? Okay. Or what is the relationship between this and machine learning? If you look at machine learning and this combination, you can look at this the 10 as some features, some variable. It can be age, gender, it can be whether you are from rural background, it can be your income, whatever it is. 10 is something which is your input variable. 3 might be the variable that you will require for your machine learning algorithm, or you want to minimize the amount of data that you want to analyze in the machine learning algorithm. That means when we talk of big data and when we talk of data, if you typically look into your Amazon data, the amount of data that they have is extremely huge, extremely huge. That means when you are registering with Amazon, they not only do the context based filtering. That means they try to look your features and try to see the features of similar purchases in your area. So if I am talking of you buying something from Amazon and you give your address as Erode, Amazon databases will automatically update it, and it will also continuously monitor what is the reaction of the same product across Erode. Point number 1. Point number two is it also looks with respect to your concept. That means it will see how many professors are buying Samsung A10 phone in Erode area, and what is their gender, what is their age, okay, and whether their family members are part of this, are part of Amazon. And no, by the moment they know that you are a professor, they know your age, the system will start generating data automatically. What could be your approximate salary? It does a salary approximation of Anna University and then tries to place your salary. So it is generating data where some of the data is what you give, some of the data is what is derived. So typically when you do a purchase in Amazon, or typically when you do whenever you fool around with Facebook, about 200-300 parameter points are captured. So I have about 200 points which are captured. Now this 200 points is for one person who is doing a purchase for 5 rupees or 5,000 rupees or 5 lakh rupees, it does not matter. But within a minute, you have about more than 1 lakh people logging out after purchasing. That means I am capturing data to the context of 200 multiplied by 1 lakh in 1 minute. Okay, so in 1 hour, I have 60 lakhs by 200 records. And in this 200, some of it are continuously being derived. And this is where you see the big data. This is where you see the velocity. Now, if I want to make a decision, my system, as it is generating the data, it has to make a decision and inform the end user. Okay, that means as the data, as you are purchasing a dress, as you are checking out, maybe millions of records are accessed, and also your algorithm is going to predict whether you will return the product or will not return the product. The moment it defines or it sees that you are going to return the product, there is a probability that you will return the product. What it will do is your return policy will dynamically change. I can change the return policy dynamically, wherein what it does is it will say instead of return window in 5 days, it might change it to 2 days if it finds that you have a risk. If you are under a very high risk person who regularly does returns, or pattern, it may not be you at all, it may be people similar to your profile. That is where the concept recommendation comes into picture, and that is where what happens is it will say no returns for you. So it may not allow a returns policy at all. Amazon has done enough research to find states, districts where there are high returns. Because what will happen is, see, you are a professor in a college, as you chit chat with your friends, you can always tell within the community inside your college, I bought it, I did not like it, I returned it. So somebody who's your friend also follows the same principle. Okay, if I don't like, if he's in two minds, he or she will return the product, right? So this is something where the concept engineering becomes extremely critical and is part of recommendation. So big data talks about big data, or machine learning is applicable for anything and everything. It can be applicable for the amount of discounts that has to be given. It can be on the returns policy. It can be on trying to find products that you might buy. Classic example is Google, where the page ranking algorithm. Typically over a period of time you start seeing, or you get addicted to Google. Reason being very simple. It has captured enough data from you and it is able to predict what you want. So the first 10 search is always what you like. If you are a typical Bing user, or if you are a typical Mozilla Firefox user, or if you are a typical Chrome user, try changing from one platform to another platform. You yourself will see that the search outcome, you'll not be happy with the search outcome. Let us say from Chrome you move to Firefox. Initially you will find that the outcome is very poor, but as you move for, as you start adapting to Firefox and start using it for a couple of weeks, the system would have learned enough for it to predict what you want. Now I was coming back to this problem of 10 products in which you find the combination. The reason I'm trying to highlight this is, I was talking of 200 points that are being captured. It can be more than that. Over a period of time, I might have about 500, 600 variables on you specifically. On an individual, I have 500 to 600 specific data points. Now for me, for a given problem statement, identifying which variables are required becomes extremely critical. So that is the feature selection part of the data science, and that is where you have the statistical techniques, or what you call as filter based techniques. Then you have the wrapper based techniques. Reason is very simple. I have this 200 10C3 instead of 10. If my combination of mobile phone or whatever is 300 and I want to pick up 5, then what happens is 300 C5 is, let me just calculate it. It is about 195 crores. 195 crores. That means your Amazon engine is, you're buying a product. Amazon engine has about 300 parameters on you. It cannot use all these 300 parameters to find out a specific character in you. It has to because the moment I talk of 300 parameters and it is trying to compute it, 300 parameters computation, the computational cost is extremely high. I have I need to look at the challenge of selecting the parameter which will ideally suit me. Though it looks only 300 parameters, and in this 300 parameters I want to select 5 parameters. The combination that is present is 195 crores. Where else, here it is 10C3, 120. Any system can solve it. Here, even the best of the cloud system will take some time to crunch these numbers, assuming that you write the program very effectively. Because the moment you try to answer and try to program this type of problems, you will see that the complexity is not order of n or order of n log n. It starts increasing either exponentially or polynomially. Could be something like order of n squared. So order of n squared, maybe 300 features is something which the system might be able to handle. 500 data points may not be possible at all. So this is the primary challenge in big data. You have various tools for handling receiving streaming data. You have various tools. You have various tools to handle unstructured data, semi-structured data. Yeah, where databases tools are available. But when it comes to analyzing the data, you do have a lot of systems, deep learning systems, you have various machine learning algorithms, but selecting the data, identifying the data and selecting the data is the biggest challenge that you need to address and take it forward. Got it? Okay. So let me start very fundamental. Though I'm supposed to talk on algorithm engineering, I'll talk very fundamentally on what data is. Whenever you talk about data, we know the variable or the point where you store the data. A variable can be a independent data or a dependent data. Now, what is independent data? What is dependent data? Is the first thing that you need to understand. Independent data are something which can change or be changed in the experiment. Okay, so I want to do an experiment. I want to study what is the impact of age, what is the impact of gender. That is what my independent data is about. My dependent data is the outcome. In supervised learning, you call it as the class label, right? In supervised learning, you call it as the class label. In regression, you call it as the outcome. That is nothing but the dependent variable. That means given five or n number of dependent variables, this n number of dependent variables which will have a given n number of independent variables. This independent variables combined together can be used to predict the dependent variable. It can be used to predict the dependent variable. So what happens is, when I am doing research or doing experiments, I can vary this independent variable and try to say what is the impact of the independent variable on the dependent variable. Okay, so alternatively, we put dependent variables are the variables that are being tested. Now please understand, each scenario it is going to be different. Now I gave you the classic example of your return policy. I gave you the example of discount. Okay, each of this will require different type of data. You cannot have one size fits all. So you cannot say I have this 300 variables, let me use all these 300 variables for the machine learning algorithm. It does not work. The computationally it becomes non-deterministic. Point number one. And you saw the example of the combinatorial problem where we had 195 crores, which is very, very huge when it comes to computation. So understanding the independent variable with respect to the dependent variable is a critical component, which is very critical when you get into big data analysis. The second thing that we need to understand is, when we are using machine learning algorithms, we use the concept called as multi-collinearity, where if two variables which are independent are dependent with each other, it has a adverse impact on the algorithm, at least many of the algorithms. So if I have two independent variables and these two independent variables are dependent on each other, then we say then this has an impact on the machine learning algorithm. Okay, that is the first golden rule that you need to understand. So the moment I have data, I have to ensure that the data are not independent among themselves. The data are not dependent among the independent data. If that is happening, then it will have a impact on my outcome. So that is one thing which you need to remember. The second part is what we called as heterodiscacity. I'll come to that later. So when we talk about variables, I spoke about the independent variable, I'm speaking about the dependent variable. When we speak about variables, you can broadly classify them into continuous variables and discrete variables. And within discrete variables, you split the variables into different types based on its characteristics. The first variable that we'll see is called as the nominal or the categorical variable. Nominal variables are unordered variables. For example, the color red and green. When I talk about color red and green, I can say green and red or red and green. It does not change the definition, or it does not change any outcomes. So I use red, I use green, or I use green and I use red. It is not going to have any impact on the outcome. So they are called as categorical variables. One thing that you need to understand is, when we talk of categorical variables, there are scenarios where you may be forced to change one type of variable into another type. That is something which I'll explain it to you. The second type of variable is the ordinal scale. It is nothing but a categorical variable with ranking. Amazon star system is a classic example of it. So if you look at the Amazon star rating system, what do you see? You see the star rating, very poor, poor, average, good, very good. Now it has a rank. I can say very poor is 0, no, very good as 5. So it is called as a Likert scale, Likert. So it is called as a 5-point Likert scale. You can have a 7-point Likert scale. You can have a 10-point Likert scale. Depends on the type of service that you are using. Typically, when you go for automobile service, they use a 10-point Likert scale because they feel that such a broad scale is required. Whereas Amazon or Flipkart might use only about 5 points. Okay, they are called as ordinal scales. Ordinal scales are nothing but categorical data with ranking. The next type of scale is the interval scale. In interval scale, now in continuous data, we see that you can have values which are not uniform in between. Like let me say 2, 4, 6, 8, 10. So there is a uniform value between 2 to 4, 4 to 6, 6 to 8, 8 to 10. The difference being 2. Interval scale is such a scale. Continuous data, you might have 1.2, 1.3, 2, 2.8, whatever it is. So interval scale is an ordered series of equal size categories. That means 2, 4, 6, 8, 10. It is called as a interval scale. Typically in an interval scale, you do not have a 0. You do not have a 0. You can set it arbitrarily or you need not worry about it. So for example, weight is the weight of each student in a class is a classic example of interval scale, provided I round it off. It is a classic example of continuous data if I don't round it off. That means if the person is 45.2 kilos, I make it as 45 kilos, round it to 45 kilos, or if a person is 45.7 kilos, I round it to 46 kilos, then it becomes part of interval scale. But if I measure as 45.2, 45.25, whatever it is, then it becomes a continuous scale. Now, understanding between interval scale and ratio scale is ratio scale has a true 0. That means when I talk about interval scale and I'm talking of weight of students, a person cannot have zero weight. Since it does not have a 0 weight, I can confidently say the scale is an interval scale. Whereas if you're looking at the marks obtained by the student, the marks obtained is, he can obtain 0 marks. If there is negative marking, he can obtain negative marks. That is a classic example of ratio scale. Okay, so these are the data that you really need to understand before deep diving into data science or big data. But it is also good to understand that it is possible to change. It is possible to change from one level of measurement to another one. The ordinal data can be converted into an interval data. Ordinal data can be converted into nominal data, or a interval data can be converted into a nominal or categorical data. That is not a problem at all. If it requires, you can do it. Okay, so a classic example could be something like this. I can say let us say I'm talking of the marks obtained in the class. Let us say I'm talking about the marks obtained in the class. Students might have obtained various marks, 25, 20, 26 or something, 45, 55, whatever it is. This is a classic example of in ratio scale. This is a classic example of ratio scale. Now, how can this be converted to interval scale? I call this as a classic case of ratio scale because I can get a 0. How can I convert to interval scale? Yes, there are a lot of tests. If I'm not wrong, even your GRE test where it is not possible to get a 0 at all. The minimum marks, even if you don't attend anything, they'll give you 20 marks. Okay, so if I state instead of 0, I am able to change anything less than or equal to 0, I can convert that into 5. then this ratio scale becomes an interval scale. Now, why should I do that? Maybe there is a requirement in the data. See, when you're looking at data, you're looking at millions and millions of records. Typically looking at 10 crore records or 20 crore records is very common. So the first thing that we do before getting into big data analysis is you do an exploratory data analysis. Similarly, a interval scale can be converted to an ordinal scale. How do I convert an interval scale to ordinal scale? Very simple. I can give the marks as, I can convert that into grade. A, B, C, D, E, F, or whatever grading system you have. That means it has become an ordinal scale. S followed by A plus, followed by A, B, C, D, maybe E is the fail. But no, the same ratio scale can also be converted into a nominal scale. I can just call it as pass or fail. I'll just call it as pass or fail. The moment I talk about pass or fail, that means my ratio data has directly become a nominal data. My ratio data can become an interval data. My ratio data can become an ordinal data. I can change it. But as an investigator, as a researcher, or a person working in big data, you need to look at the impact of changing this. The advantage you have is the processing time increases dramatically. The processing time, the moment it becomes categorical or ordinal, the processing time, because the amount of data that is available for computation is extremely low. But if it is going to be ratio, it is going to be painful. Now, what happens if I have continuous data? What happens if I continuous data? When I have continuous data, let us say I'm talking of marks. So no, you have a marking system where we talk of 1/4 of a mark, we talk of half mark and things. That means a student can get 55.25 marks, 55.5 marks. Again, that can be considered as interval data or a ratio data because it has a space of 0.25. It can be considered as a ratio data. Alternatively, if you want to consider it as a continuous data, absolutely not a problem. Now, this continuous data can be converted into an interval data by doing binning. What is binning? Binning is nothing but the process of forming bins. I'll say 0 to 5 marks, 6 to 10. I can form bins. I can find the number of students and convert a continuous data or a ratio data into smaller set of data which can help my computation. It is absolutely of no use to work with very large data without doing some sort of data transformation. Most of your algorithms will fail. Imagine maybe if you have used any of these tools like basic Python, or if you have used R, Vika, Orange, any of this data mining tools. If you use their standard data set, any of the standard data set that is available in the net, like your German credit card or your Hart data set, any of this you use, it is only in thousands. At the most, it can be in lakhs. You don't see the problem. But here I'm talking of the starting itself being about 10 million. Okay, that means at least 1 crore plus records. In that case, if you do not do this, you can expect your algorithm to run for a couple of hours. And I was talking about the 300 variable in which you select 5 variables. I was talking of 195 crore combinations. Yes, in research, I can afford to do that. Typically, when I do research, I have algorithms which runs for 8 hours, 10 hours and things like that. But I don't bother about it because now I switch on and go to sleep. Or now I don't use that system, or I don't use that particular virtual machines. But if you are trying to use it real time, then this is going to become a problem. That is where this data conversion becomes extremely important. So remember, a continuous data can be converted into an interval data or a ratio data. A ratio data can be converted to an interval data, or an interval data can be converted to an ordinal or a nominal data. And Vice versa may be possible, may not be possible. If you have a nominal data, you cannot say that I'll convert that into an ordinal data, becomes challenging. So now as we move forward, I'll also show you some examples where the candidates are good for converting from ordinal data to nominal data or interval data to ordinal data. Okay, so this is where human intervention is required, where you need to analyze the data and take it forward. Typically in big data analysis, when you are creating your own algorithm or you are investigating an algorithm, you do not use the whole data. You do not use the whole data because you have a 10 crores records or 20 crores records or 30 crore records. The biggest challenge that I'll face is if I make a small change in the algorithm and run it on the 30 crore records, I'm going to have severe problems because it may run for 8 hours, 10 hours, 12 hours, or 24 hours, whatever it is. And if my outcome is no, I'm not happy with the outcome, I need to change the algorithm, I need to change the algorithm parameter, then again I have a problem. I need to go back to my modification of the algorithm and run it. But what we do here is, in real life, when we are working with big data, we take samples from it. So the entire data that is available is called as the population, and if I take a small set of data from it, I call it as the sample. When I do this sample, I need to ensure that statistically the data is not, the data has not come from some extreme of the population. Because typically what happens is we assume that the population is a uniform distribution. Okay, it is a uniform distribution, a Gaussian distribution, a normal distribution. We assume it is a normal distribution. So if it is either a normal or a Gaussian distribution, either both of it is the same. The formula is very typical, no? 1 over square root of 2 pi sigma squared into e to the power of minus of x minus mu whole squared by 2 sigma squared. That is the thing that follows. And if I have a normal 100% normal distribution, then mean equals median equals mode. But in real life, you never have this. You never have this. Your data will be highly skewed. The moment it is highly skewed, you can be assured, you can be very assured that your data will be highly skewed, something like that. You can be very assured your algorithms will fail miserably. So this also applies to your research problems. Okay, so when you take a sample, you will have to ensure that the sampling error is minimal. The sampling error should be as minimal as possible, and you need to check with various techniques to find whether the data sample that you have taken follows the parent. So that is where your descriptive statistics come into picture. Though we talk of mean, median, mode, standard deviation, and other things, it becomes extremely important before using the algorithm to use the basic descriptive statistics to understand and analyze the algorithm, understand the data. So I was talking about the frequency distribution. It's very straightforward. I can do a distribution, the number of, based on the shirt color, I try to find the numbers. It is where I try to put it in a very organized way. Whenever I use a frequency distribution, histograms are pretty popular for displaying the data. Do remember, especially if you are planning to go to the industry or you're planning to be part of the industry, two things are extremely important. Though you may not be directly taken as a data scientist, the industry is also looking in for a lot of data analysts. When we talk of data analyst, it is nothing but analysis of data. Two components come into picture: descriptive statistics, a little bit of inferential statistics, and more of EDA. So when you talk of EDA, generally, though the terminology is exploratory data analysis, the trend is to show the data as a graph. Okay, show the data as a graph. So for you to understand EDA, you need know, for understanding the basic of data analysis, you need to understand when to use a pie chart, when to use a bar chart, when to use a heat map, when to use a box plot, when to use a line chart, right? So you need to understand how to do a univariate analysis. That means analysis of a single variable, bivariate analysis of two variables together. Maybe I'll try to see the color versus gender when I'm talking of multivariate, bivariate analysis. Or I can look at a multivariate analysis, which is color versus gender versus age, right? If you are able to see an organized picture, that is the entry point for you all to get into the industry. So no, this does not require rocket technology for uh, understanding Python. If you have basic idea of Python with a strong knowledge of uh, inferential statistics and descriptive statistics, getting into the industry is extremely easy. And with so much of work from home, looking for jobs become adapting to a different field becomes pretty easy. This is something whom they call as data analyst or data analyst, and there are a lot of openings. And here there are a lot of special tools also. Excel, you would have made some graph for your research paper. You would have used Excel to make some graph, or you would have used MATLAB, or you would have seen the outcome of VCA or R, where it is not very beautiful. You have then that is where we try to use Python. And when we're talking of Python, typically matplotlib is extensively used. The library matplotlib is extensively used. Now, there are also specialized softwares which is very popular in the industry. One very popular tool is the Tableau. Okay, Tableau is SPSS is one more tool which is pretty popular. Tableau is a visualization tool which is extremely popular. If you are able to use it, then it becomes very easy. IBM SPSS is extremely easy to use. It is in fact easier than Python. And when you look at Python, it is much easier than either Java or your basic C language. Python is very easy to use because it is an interpreter, uses scripting, has a lot of libraries, functions to take your task forward. You have Tableau, which gives you, a better look and feel, and it gives you a better where the learnability curve is extremely low. You sit on Tableau for 3 days, you can understand how Tableau works. But if you have the statistics data and if you have the idea to analyze data, then as a data analyst, you can definitely get into the industry without knowing rocket technology. It's a continuous learning process because when you look at the data science industry, it evolves every day. It is like the .com industry sometime during 2000, or not even 2000, it is sometime during 1990. We had the .com burst 1990, 1992, where we are talking of emerging technologies changing continuously. There is nothing to worry. But as long as you know the roadmap very correctly, taking it forward becomes very easy. Okay, so I've been talking for 1 hour. Let me stop my share. I'll take some questions if anybody has questions. Anyone has questions before I continue? Anyone has questions now?
I have one question, sir. When we talk about the variables odd the interval,
Trying to talk? You're not audible.
yeah.
Oh, sorry. Jayabharti, can you just repeat your question?
Sir, when we talk about the variables ordinal and nominal, ordinal and interval, we are giving the interval values to the orders A, B, C, D. So both are interval also can be told as ordinal, sir.
Yes, interval is the ordinal data, but the range is going to be very large.
Very large. Okay.
If you take, ordinal data, the range is going to be small. In fact, When we do statistic analysis and when we find that the distribution is not normal, we call it as non-normal. When the distribution is non-normal, we consider a interval data as a ordinal data. Okay, so if you are doing any hypothesis testing, no, you want to accept or you want to reject a null hypothesis, if you are doing a hypothesis testing, and if the data is non-normal, okay, we apply many of the ordinal techniques for the interval data. That means I cannot use a student t-test, I cannot use a student t-test, or I cannot use a z-score test. I may use something called as a Wilcoxon test, which focuses more on the ordinal data. So yeah, you can convert. That is what it depends on the data. It depends on the application. If the interval data you don't want, you can convert to ordinal data. But if the interval data range is very small, between 10 to 40 alone, you can also consider it as an ordinal data. Absolutely not a problem as long as it has a rank.
Okay, sir. And you told me the bin value. That bin value, the interval value, sir. For example, 240 to 320 is my interval value. How can I mention the bin value? Whether I have to mention the range?
Yes. So your bin will start from 240. So your bin will start from 240. See, what will happen is, let us say the size of the bin is 10. Okay. The size of the bin is 20. 240 to 260, 260 to 280, 280 to 300, 300 to 320. This will be your bin value. Alternatively, if you want it from 0, then you can have bins for 0 to 20, 20 to 40, 40 to 60, up to 240. If
So
you
the
feel
bin value, I have to give the range or a starting value I have to give, sir?
See, it depends on the software that you are using, but theoretically you have to define a range. So when I say 20 to 20, when I say 20 to 40, what it exactly means is, it means 20 to 39.999. It is not 40. Theoretically, we call it as 40, or it will be 19.999 to 20, 40. Okay.
Okay. Because when we are going to find the histogram, the bin value is very much important. That's why I asked.
Correct. See, most of it depends on the software that you are using. Some of it might where you need to specify the bin values. In some, you can give the auto feature. But now, if you are able to specify the bin values, visualization becomes much easier. But if you are looking at the bins which are less than 220, and if you don't have data, and you still want to consider that as a bin, what will happen is the data will not become normal. It will become negatively skewed. Because initially the bins are going to be 0, so the data will be negatively skewed. That is something which you have to be very careful when you are doing research.
Okay, sir. Okay. Thank you, sir. Thank you.
Anyone else? Anybody? I can answer one more. I can take one more question. Anybody wants to ask questions, doubts? Okay. Fine. So let me go back to my. I hope you are able to see my screen, right? Yes, somebody can give me an S sign.
Yes, sir. Yes, sir.
Thank you. So now I will not get into the definitions of mean, median, mode. Mode is generally used for qualitative analysis, or no, it is used for categorical data only. Mode is used for categorical data. Frequency is used for categorical data only. It can be used in interval data, but you need to handle it very, very carefully. It does not I cannot say mode will not come for interval data. It can be there, it can be used. You need to understand the data intimately before using it. Median is used for extreme scores. Please understand, mean will fail when the scores are extreme. Let us say the marks obtained by the students in the class are about 40, 35, 25. I who has scored say 26, then I have somebody who has scored 100. Okay, somebody who has scored 100. Now, if I calculate the mean, If I calculate the mean of this, I have 80, 115, 140, 166, 266, 266 divided by 6. 266, am I right? Yeah, I have got 3, 5, 6. It is 266. So 266 divided by 6 will be approximately 45. So it shows the mean is 45. So do you think the class average is 45? No, the class average is not 45. If you see, this 45 was achieved because of the extreme value 100. Now, if you assume there was, so this is where the problem of mean comes into picture. I have multiple ways to handle this data. I need to find the kurtosis. I'll explain what kurtosis is and take a decision whether this has to be used in my computation. Alternatively, I can find the median. So median, I put it in ascending order. No? So I need the average of the fourth and fifth, third and fourth value. So 25, 35, 25, 26. How do I find the median? I have 25, 26, 35, 40, 40, 100. Right? So it is going to be the average of these two values since it is even numbered. 75 is going to give me 37.5. 37.5 is much closer to the scores that is obtained here, whereas 45 looks very, looks more on the higher side. If you see 45, nobody has scored 45, but my mean shows the average class in the marks in the class shows as 45. But if I look at 37.5, I can point 3 people, 2 have scored 40 and 1 has scored 35. Got it? So this is where you need to know, whenever you have outliers or extreme data, you have to use median. Okay, mean can be used when there are no extreme data, and mean cannot be used for categorical data. Correct? You cannot find. No, that is one big mistake I see among a lot of people. So when somebody might have written the categorical data as something like this, what they would have done is red equals 1. I can do something like this: red equals 1, blue equals 2, and green equals 3. I have seen so many people taking the average of this. Do you think it will give you a convey anything? It is a categorical data. How can you take? No, red is 1. So if I take the average of this, I'll get some 3. Does it carry any meaning? Absolutely no. So be very clear when you have categorical data, use only mode. And believe me, why I'm stressing this so much and why I'm trying to tell you that going to the industry is very easy is I find people from the industry struggling in this. And of course, no, they are all your students or my students, right? So your students are only working in the software industry, and you know how good they fared in statistics. And this is what I see. They make a lot of mistakes here because the moment it sees as 1, 2, 3, and if I use Python and I say find the mean, it will give me the mean value. If I say find the median, it will give me the median value. But the data is extremely wrong. So once you do this and give it to your machine learning algorithm, that is going to give a wrong answer. So it will have a cascading effect. If the data, whatever data you have made a mistake in the initial stage, it will have a cascading effect and the entire outcome will be wrong. At the most, what will happen is you will have overfitting of the data. Rather than underfitting, you will have overfitting of the data, which will ensure that the test data, the training data works extremely well, but the test data will fail miserably. That is where your other parameters like precision, recall, and all play a very crucial role. Okay, so mean, median, mode, I will not get into the formula. The next thing that you try to understand is the variability. When you look at variability, we talk of, I don't know whether you would have heard of range, but standard deviation and variance is something which you would have come across regularly. Range is nothing but the value between the highest value and the lowest value. So if you are looking at the marks obtained in a class, 95 is the highest value and 15 is the lowest value. 95 minus 15, 80 is the range for that data or for that variable. This is very important. Yes. I have one for some data. 9 minus 1 is the equals 8 is the the range. Standard deviation. Yes. Now, when we talk about standard deviation, there are two formulas for it. One is with respect to the population. The second is with respect to the sample. I told you the sample. No, you cannot. At some places, it is not possible to look at the entire population. And the definition of population also will change dynamically. For example, you take your COVID testing, that is the Covaxin or the vaccines for COVID that is being tested. Russia has a successful model. He has deployed in Russia. Okay. How did he do it? He took a sample from the population. Then he split the population. Yeah, he split the sample. One were given placebos. That means they were just given distilled water. The second group was given the vaccine. Then they saw the impact. They found that there are no adverse reactions and there was an improvement. They are able to prove that the vaccine is able to, if the person is exposed to COVID, the vaccine is able to stop it or build the required antibodies to fight the antigens. Simple. But the same vaccine cannot be, now Russia claims it has tested for the population. When it says it has tested for the population, it means the Russians, because when the sample was taken, they had not taken people from India. Whereas, so what happened is once the drug becomes successful, here Dr. Reddy Laboratories took it and they are doing the testing now. So the Russians sent the vaccine Sputnik 5 to Reddy Laboratories. Reddy Laboratories is testing it now. And once they are able to see the human trials in India for Indians, and if the efficacy is good, then the product will also be released. Okay, so sample plays a very important role, but the definition of population can change dynamically. You need to be very careful on that, because what is the preference of buying? If you are looking at when you look at definition, somebody is buying an Apple iPhone, and if you are working for Amazon, you have only Amazon data. So if you are working for Amazon, then Amazon's data will become your population. If you are working for Flipkart, then Flipkart's data will become your population, on which you can take a sample to identify who is buying the mobile phones. But when it comes to iPhone has the data from both Amazon as well as Flipkart. So he looks at the entire thing, the entire population. So the context is extremely important when you're talking of population. Here the standard deviation formula is for the sample. Okay, see, remember, whenever you use sample, the mean is represented by x bar, whereas for a population, the mean is represented by mu. The standard deviation is represented by S for a sample. For a population, it is represented by sigma. If it is going to be, if you are computing the standard deviation for a population, no harm at all. This n will not be present. -1 will not be present. That's all. No major changes at all. In fact, when the sample size increases, it really does not matter whether you are using n or n-1. Now, what does this mean? Now, how do you understand? Though standard deviation is something which we regularly see, you need to understand this intimately for you to understand data. Okay, so generally when we talk of data, one of the normal assumptions, we call it, one of the normal assumptions that we make is the data is uniformly distributed. What does this uniformly distribution means? We say, let us say this is the marks obtained by students in a test. You have 0, you have 100. Maybe the average marks scored by the students in the class will be about 50. 0, you will have very less number of students, or you may not have any students. 100 also, you will have very less number of students. But as the number of people, as the most of them will score around 50. But there can be scenarios where many have scored 70s. That also is possible, which can be found using your mean. But the standard deviation gives you a better idea for the entire class. So let us say this is the marks for 0 to 50 is the marks. Let us say the 50 is the mean Let us say 10 is the standard deviation. What does 10 indicate? For a normal distribution, 10 indicates, okay, we call it as one standard deviation. One standard deviation equals 50 plus 10. Minus one standard deviation equals 50 minus 10. So my data is between 40 to 60. So if I plot that data, 40 will be somewhere here, 60 will be somewhere here. This part will comprise of 68% of the data. That means if in a classroom of 100 students, if the mean score is 50 and the standard deviation is 10, then very confidently you can state 68 students have scored between 40 to 60 marks. 68 students have scored between 40 marks to 60 marks. If I take plus 2 SD and minus 2 SD, if I take 2 SD, that means 50 plus 2 into SD, standard deviation is 10, so 70, 50 plus 20 is 70, 50 minus 20 is 30. You can be assured that in a normal distribution, 95% of the data falls between plus and minus 2 SD. That means 90% of the students, 98 students, out of the 100 students, 98 students have scored between 30 marks to 70 marks. That is how you'll have to interpret your standard deviation. Standard deviation, mean, median, standard deviation, along with skewness and kurtosis. If you are able to understand this, half the battle in your research, if you are doing research in data mining or no, whichever area related to data, half the battle is won. You can literally work only on this, and that is something which can help you in identifying the algorithms and taking it forward. Variance is the square of standard deviation. Other important parameter is called as the quartiles. See, here I'm talking of handling 1 crore records, 2 crores records. Okay, quartile is nothing but you again see in median. What did you do? You put the values in ascending order or descending order, then took the center value. So that is what you see here. If you see, the median is also called as quartile 2. It is, I have taken the ascending order and taken the center value. Now I can also find the first quartile, which is nothing but 1 by 4 into n plus 1. That means if there are 100 records, my median is going to be the 50th record, the center value. Assuming we have 100, 0 to 100 records. Then the 50th value will become my median. Whereas 1 by 4 into n plus 1, that means 1 by 4 into 100. 1 by 4 into 100 plus 1 is 101, divided 101 divided by 4 is 25.25. So I can take it as 25. That means 25th record is called as my lower quartile or my first quartile. Q2 is called as the middle quartile or the second quartile. Third quartile is the upper quartile, which is the 3 by 4th term. Why is this important? This becomes very important. No, here if you look, there are 11 records. So 3 by 4 into 11 plus 1 is 12. 36 by 4. 36 by 4 is the 9th record. That is what you are seeing here. It is the 9th record. So quartiles are very useful. Why? Because we assume that in a normal distribution, the data follow, most of the data falls between the first quartile and the third. The quartile can also be used for identifying outliers. The biggest challenge for you when you work with big data is outliers. It can be a typing error. No, instead of typing the age as 12, they'll type it as 120. Or instead of typing gender as male, they are typed as male and female. So these are outliers, data which is not falling in regular terms. Now, these quartiles can be useful to identify outliers. Okay, the interquartile range or the IQR or the quartile formula is Q3 minus Q1 gives me the interquartile range. Q3 minus Q1 gives me the interquartile range. Most of the data will fall within that. If the data falls within the interquartile range, then you can be extremely happy to use any of the big data algorithms. If it is not so, then using any machine learning algorithms, you need to select the right machine learning algorithm. If there are a lot of outliers, I cannot use a logistic regressor classifier. I need to use a decision tree. So that is something which is extremely critical. Now, if I am comfortable only using logistic regressor, or I am forced to use logistic regressor, then I need to find the outliers and eliminate it. That is where the challenge will start. So this is what I was talking of. Most of your data is always a normal uniform curve. Now, even if you do the binning, even if I do the binning, my bins will be something like this. Okay, my histogram will be there. If I draw a smooth curve, that is what I call as my, normal distribution curve. You normally see in the center. But if all the students have scored very low marks, what would have happened? My graph would have looked something like this. If most of the students are very intelligent and we have very less students who are who score less marks, then my outcome would be something like this. If I have data like this, if it is not uniform, then I am going to have a lot of problems when it comes to using big data algorithms. Most of the big data algorithms fail. And this is the place where you can master, and this is the place where when I talk about openings in data science, this is the place where I see a lot of people struggling because they don't understand the concepts of basic statistics, or they don't understand how to read data. See, I'm doing a simple plot. Once I do a simple plot, if I'm able to analyze the plot, then it's a very good step forward for me to analyze the data. So generally, this is what we call as EDA, or exploratory data analysis, where the first thing we try to see how the data is available. Here I'm looking at the I'm looking at data which is highly normal distributed. This is again normally distributed. This is also normally distributed, but it has two modes. Okay, this is called as a unimodal distribution because there is going to be one value which has the most number of repetition. Assuming this is the marks, then this will be the mode value which is going to be 50 marks on 0 to 100. Whereas this is called as a unimodal distribution, bimodal distribution, where I have a lot of students who have scored 45 marks and I have a lot of students who have scored 75 marks. Equal number of students. 20 students have scored 45 marks, 20 students have scored 75 marks. Again, though it is a symmetrical distribution, there are many challenges because here it is a multimodal, where we call it as bimodal. I can have a trimodal, I can have a multimodal distribution. I was talking about the positive skewness. This gives a lot of information. And one of the most important concepts when it comes to big data analysis, it is called as skewness. If the mean is not in the center part, then we can confidently state that, or the data is either positively skewed or negatively skewed. When the mean is greater than the median, we can confidently say the data is positively skewed. If the mean is less than the median, then the data is negatively skewed. We'll start understanding that more in detail. Okay, in positively skewed distribution, the scores are higher on the left side. Okay, that means in a class of 100 people, if many of them score less marks, then it is a positively skewed distribution. Do not get confused. You can use that as a formula in your mind. If the number of students who have scored less marks is high, then we call it as positively skewed. Alternatively, if more number of students have scored more marks, it is negatively skewed. How is this useful? This is the primary step where you can find outliers and eliminate outliers. This is the state where you can find the outliers and eliminate outliers. The formula for skewness is 3 into x bar minus x tilde. That means 3 multiplied by mean minus median divided by standard deviation. If the skewness in your data, whatever data you have and you're doing research, if the skewness is between -3 to +3, you need not worry much about it. Generally, ideal value would be -1 to +1. -1 to +1. But if you get a data up to -3 to +3, you can still go ahead using any of the big data algorithms. But if it is going to be greater than -3 or greater than +3, you need to do data pre-processing, or else your algorithm will either overfit or it will not perform well. Okay, so before doing any experiment, you need to basically identify whether the algorithm is capable of handling the data. Okay, so you have 20 records and you have a couple of continuous variables or interval variables. You look at the skewness of the data. If the data is skewed, you are going to have problems. Got it? The same might be applicable to categorical also. If the number of categories are very high, if the number of categories are very high, then you need to look at it. But see, I'll give you a simple example. It can be gender can be male, female. But in today's we need to look from the legal perspective also. In India, it has become a law now. I have to give male, female, transgender. Some countries it has become male, female, transgender, not willing to state my gender. Then I don't want to state my gender. Human rights, right? So this is where the various fight is happening between the organizations like Facebook and Apple, or Facebook and Microsoft, Apple and Microsoft. Very simple example, how you look at data. I'll tell you, Facebook does not charge you money. Facebook uses your data, because when you're logging into Facebook, you put yes, accept. It will say, no, I'll use your data. I'll use everything from your, whatever you type, I'll take it from you. It will say, I'll take your location. I'll find your mobile number. What is your mobile type? Everything it will capture. Then it uses that data to sell products to you. When I say it sell products to you, Facebook is not selling the product to you. Facebook is making you buy the product by showing the product continuously. Okay, Facebook is making you buy the product by showing the product continuously, period. Imagine you have TVs. Okay, initially maybe the usage of when people bought TVs, it was very rare. But now TV has become a necessity. Once upon a time, TV was luxury. Washing machine was luxury. Now it has become a necessity. How is it being made now? Now it is growing faster because Facebook does the advertisement. Whereas Apple does not do that. Apple charges you for anything and everything. You want to use an app, it will say buy the app. It might be 40 rupees, 80 rupees, 100 rupees. You also don't mind buying it. So Apple's revenue comes from subscriptions of apps, selling of product. They sell their iPhone. Whereas Facebook revenue comes from advertisements. Now, Apple has come out with a rule where, with a software change, where you can go and say block all the privacy, block privacy for any given application. That means I install an application, I install LinkedIn or I install Facebook, I'll say block privacy. The moment I give block privacy, Apple operating system will ensure that none of the data goes to Facebook. Now, what is happening to Facebook? They are profits are coming down. So both of them are fighting. So no, how you look at data, the data will change very dynamically. Court might rule, but no, recommender system is the future, and no, unknowingly all your personal data is being used continuously. Google tracks you. Even if you switch off the phone, Google still tracks you. Okay, so you have an Android phone, Google knows where are you, how are you, now all this thing it shows. And it also, even if you keep your mobile phone off protects to a certain extent, but it does not protect you completely. So that is a type of a way the data is being used, and that is where skewness might play an important role. Some countries might say gender, male, female, transgender is compulsory. But the population of transgender might be very low, or the population of people who do not want to specify their gender might be very low, in which case I need to take a decision as how to work with the data, or else it is going to give me a lot of problems. The next critical component when you're looking in big data is courtesies. Courtesies indicates how much data is in the tails. I have my distribution like this. Courtesies value will tell me how much data is here. If I have a negative courtesies, then I can confidently say that the number of data which is in the borderline is very less. Number of data here is very less. So I can think of eliminating the data in my research or in my algorithm. I know if I'm using it with the algorithm. But if I have a positive courtesies, then I'm going to have challenges, because if I try to remove them as outliers, or if I'm trying to use some confidence interval to remove the data, that is going to create problems. So courtesies is the fourth moment. You have the standard variance, standard deviation, which is the first moment. My second moment is my variance. My third moment is my skewness. My fourth moment is my courtesies. Okay. So when I talk about courtesies, we have something called as mesocurtic, leptocurtic, and platycurtic. Mesocurtic means a normal distribution. The moment I say normal distribution, 1 over square root of 2 pi sigma squared into e to the power of minus of x minus mu whole squared by 2 sigma squared. Normal distribution. Leptocurtic, which has very lot of peaks. When you see the data like this, you will see lot of data here. This is called as leptocurtic. This is the one where, we also call it as positive courtesies. This is something where you cannot ignore the data which are on the extremes. You will have a lot of students who have got 0 marks. You will have a lot of students who have got 100 marks. Platycurtic or flat is the one where the outliers are very minimal. Okay, that means the tail region has very less number of data. So you can consider them as outlier and eliminate it if the value of courtesies is negative, and you can eliminate it happily so that your algorithm performs better. The moment you reduce the tails here, your skewness will decrease. The moment your skewness decreases, it follows more of a normal distribution. Once it follows a normal distribution, we can be very safe and state that my data is today, my data can be used for analysis. So I was talking about the normal distribution. So are you able to understand my -1 SD, my +1 SD? This is exactly what I was trying to tell. So this is exactly what I was trying to tell. But when I say -1 SD, +1 SD, I'm assuming I'm normalizing the data and then computing it. Okay, so theoretically you will never get a distribution like this. Though most of the textbooks will talk only about normal distribution, in real life you'll never get normal distribution. In real life you always get distribution which is either positively skewed, negatively skewed, heavy tail, low tail, whatever it is. But it is our duty to ensure that it follow some sort of normal distribution before we take it to any algorithm in big data. Why I am stressing on data is, I believe very strict, firmly believe, keep it simple, stupid. The KISS principle. Use the simplest of the algorithm, but you prepare the data, you understand the data intimately, and the best part is use the simplest algorithm. It can be a simple K nearest neighbor algorithm. It can be a simple Navy-based algorithm. Forget your conventional, convolutional neural network, deep learning techniques. If you are able to get good outcome in KNN and Navy-based, then getting into neural networks or advanced techniques is much more easier, because the computational time of your K nearest neighbor and all is extremely low. So even if you have huge data, training and testing it becomes extremely easy, especially if you have a sample. But no, okay, once the sample size increases, we'll have to worry about it more in the population. But the sample gives me the confidence that my hypothesis, whatever hypothesis I have set, will definitely work. Got it? Okay. So now I'll just stop here. I can take questions for 1 minute. Anybody has questions, you can please ask me. Any questions on data? You have understood? Don't assume it is elementary. They are the building blocks for your big data or
So good morning, sir. Sir, I have a doubt that so practically, like if we have a raw data, like once.
Can you come from first?
So what?
Yeah.
Sir, actually, I'm outside, sir. Like if we have a raw data, what is the first step we have to do, sir? Like you have said, skewness, courtesies. So what is the first step I have to take and to proceed with the algorithm? The step-by-step flow. Actually, I need.
The first thing that you need to do when you start with the raw data is to find missing values. Okay. So you need to identify the missing values. You need to find the number of, because see, when in industry, typically what happens is the moment they give a data science project to outsource it, what they do is they, Nilam, I'll take your question next. What they will do is they will give the entire data. So it will be very crude. It will be horrible. Cleaning the data itself takes 2-3 months. First thing is you need to find the missing values. If the number of missing values is more than 20% of the total data, you need to take a decision whether you want to use that data variable or whether you want to eliminate the variable and eliminate the variable and not use it in your machine learning algorithm. That becomes your first challenge. Second is, if you feel that data is critical and still it is missing, we use a technique called as data imputation, wherein I replace the missing value. There are many techniques. I can use the mean value, or if it is a categorical data, I can use a mode value. I can try to find, its relationship with some other variable, and based on that, I create a regression or create a system which gives me a logic between these two variables. I can fill the missing values. So that is the first part that you do. In the next stage, you see whether you have outliers. Outliers can be common sense outliers, where age instead of 16, they would have changed, it would have come as 160 or 163, which is a typing error. Okay. When you look in real-time data, there will be a lot of data which you cannot interpret at all. Age is something which you are able to interpret, but for that you require domain knowledge. Now, if you're talking of age, I look at outliers, whether I have negative values. If I have negative values, if I have positive values, there are two things that I can do. I can eliminate the data if it is 2 or 3 records. Alternatively, I can I can impute the data. That means I can use an algorithm to find the missing value and replace it with the missing value. With this, my outlier is eliminated. Outlier means wrong entry or no entries which are extremes are eliminated. My next step would be then to go for, my next step, when I'm talking of this elimination, I can give you a simple example. If you're looking at salaries, if a person is not working, I'll put it as 0. Okay, if a person is not working, I'll put it as 0. And and I can also try to find, in the entire sample or in the population, the average salary is 3 lakhs. The average salary per annum is 3 lakhs. But you have a couple of people, and that means my average is 3 lakhs. Let us say my standard deviation is 1 lakh. Then my plus 3SD is going to be 3 lakhs plus 3. 6 lakhs is going to be my plus 3SD. My minus 3XD is going to be 0. Correct? If my salary is 3 lakhs, average salary is 3 lakhs, plus and minus 3, and my standard deviation is 1 lakh, plus and minus 3SD is going to be 0 lakhs to 6 lakhs. Now, I might have a lot of records which are between greater than 6 lakhs and less than 20 lakhs. Now I can do a couple of things. I can create a new variable called as 6.1 lakhs or 7 lakhs. And all values greater than 6 lakhs will be converted as 7 lakhs. That is one method. There is a trimmed method where all the values greater than 6 lakhs will be made as 6 lakhs. Got it? Now here, this is the place where you get a lot of mistakes also. You get something called as P, or it can be some variable called as A. You will find that it is pensioners. Now, if you say 0 salary, how do you want to categorically find out whether a person is working or whether he is a pensioner? The pensioner will have 0 salary, right? These challenges you will have to address only by understanding the domain or asking your client. In real-time scenarios, we escalate it and ask the client. Okay, so once that is done, I have done the imputation of the missing values, I have identified the outliers, then I eliminate the data. Now I do the basic statistics. I find if the range is very high, I try to find, and if there are a lot of extreme values, then I go for the median. I find out, I try to find whether it is a normal distribution. I find the skewness, I find the kurtosis. If the kurtosis is positive, then I'll also ensure that my extreme values I'll not remove. But if my kurtosis is, if my skewness is greater than 3, then I try to analyze the data again, and I try to see whether try to convert the data, transform the data, or use some technique so that the skewness can come down. The skewness can come down by just changing one parameter, one extreme parameter. Instead of 0 salary, I start considering from 30,000 rupees salary. Then my skewness from somewhere from minus 18 might come to minus 3 or minus 2, which again makes my data clean. Much easier for the system to understand. Got it, Karpagam? Any other questions?
Yes, sir. Thank you so much, sir. Thank you so much.
Yeah, I think. Yeah, there's one person who had raised his hand. Who had raised his hand? I think I forgot. Somebody has a question?
Sir, I have one question. Sir, if my data set has, for example, for 2 years, they have one values. After 5 years, the students are this much percentage of the students are passed. After 10 years, this much percentage of the students are passed. So if I go for any predictions, okay, so what will be the percentage of the students will be passed after 15 years of an institution? Whether how my training data set should be, sir, whether it should consist of the 2 years, 5 years, and the 15 years data also should be there, or either it can be of 2 years, 5 years, or 10 years is enough.
Whenever in data research or in business, what is the outcome? If you are able to tell what is it you are trying to predict, you want to predict What is it, the outcome you want to say? You have the data for 2 years, 5 years, 10 years. That means you have data for the last 10 years. And are you trying to predict what will be the admission or what will be the pass rate 3 years from now? What is it? What is the outcome? That is one outcome. Or we want to find what is the quality of teaching 10 years back, 8 years back, 6 years back, 2 years back. What is the outcome? That is very important.
Okay. Okay, sir.
Okay. No, what is it? If you tell me, I can give you the solution accordingly. What is the outcome? Are you trying to?
After 15 years, what will be the outcome of my institution? How many percentage of the students will be passed?
Okay. This is the classic case of looking at it very slow, looking at it as a simple problem. It is a linear regression problem. Okay. I can have the year-wise, student-wise, and build a linear regression model. Or if you are taking more than one parameter, I might call it as a multiple linear regression problem. But
Okay.
this is not a linear regression problem. You need to take multiple parameters. See, if you look at engineering colleges till 2000,
Yeah.
number of engineering colleges were very less. Then ASD made a policy to increase the engineering colleges. Now ASD is again coming out with a policy to decrease the engineering colleges. Right?
Yes.
If that also becomes a parameter, that means the political input becomes a parameter, ASD becomes a parameter, your quality of teaching becomes a parameter, and the number of students are passed out. No, you have the training data, you have the known data. From there, using a multiple linear regression or a multivariate linear regression model, you'll be able to sort it out. If it is not a linear regression, then you need to look at whether it is a polynomial regression, in which case you need to go for different algorithms. That's all. But it's a regression.
The training data set, whether I should have the 15 years data also should have
Yes, more than that.
for prediction of.
There are two ways to look at it.
More than that.
I would do it in a slightly different way. If I am the researcher, yeah, normally they'll say do it for 15 years. If you have more the data, better it is. But I would prefer doing it in a different way because geographically, politically, the scenario is changing. When I say geographically, colleges, new colleges might be coming next to your existing college. So when we're talking of such scenarios, I would say study the first 5 years data independently, the second 5 years data independently, the third 5 years data independently. Try to understand the outcome. Then maybe try to build a model for the next based on the last 15 years data, so that you can predict for the next 5 years.
Okay, so I can have the 10 years data distributed the 10 years data evenly independently. Then I have to go for the 15 years data.
Correct. It will be easy. You study only for 5 years. The last 5 years, previous 5 years, previous 10 years, previous 15 years. Independently, you study previous 5 years, previous 10 years, previous 15 years. You do it independently. Then again you start combining all together and see, so that there is a method to the madness.
Okay, sir. So I should have the training data for that 5 years differently. I should have the training data.
I'll not say it is training data because here we are talking of regression. So use the word, if it is supervised learning, I use it as training data. Here, you have the outcomes.
Okay, sir. Okay.
Any other questions?
Thank you, sir.
Thank you. Any other questions? Somebody is here from Excel? No, I think then no. Now it's 11:50. I think can take a break and start again at 2 o'clock. Anybody in Excel here in this group?
Yes, sir.
Thanks, Jayapurni. So no, I'll drop off now and join by 2 o'clock. Is that good enough? It's 11:50 already.
Yes, sir.
Okay, fine. No, I'll join at 2 o'clock. So afternoon session, I'll talk a little bit on algorithms, but again, focus slightly more on data and get into algorithms. Thank you all then. Fine, Jayapurni, I'll join at 2 o'clock. Thank you.
Okay, sir. Okay.
Thank you.
It was very interesting, sir, the session.
Thank you, participants. Again, the session will be started 2 o'clock. தேங்க்ஸ் மேம். நான் அன்மியூட் பண்ணி உள்ள வரதுக்குள்ள நீங்க பேசிட்டீங்க. பரவாயில்ல. என் பேரா? மேம் என் பேர் மேல இருக்கும். நான் சுரேஷை தான் அட்மினா வச்சு அட்டண்டன்ஸ் அந்த ரெக்கார்டிங்லாம் பண்றோம். அதனால அந்த இதுல தான் அந்த லாகின்ல தான் நான் பேசுவேன். ஆனா என்னோட இதுலயும் இருக்கும்.